We're talking about solving quadratic functions using the square root. And so we have some examples that we're going to go through. And we still want to stick with the process that we've learned before of GEMDES. And first thing we have to look for is addition and subtraction, and then multiplication and division. Then we can go to the exponents from there. But we want to use square roots when the b value in the standard form of a quadratic equation is equal to 0. So in this case, if b is equal to 0, 0 times x, that term drops out, and we're just left with ax squared plus c equals y. So the b term is missing, and then in this situation here, that's when we can solve using the square root. So as we can see, we have the ax squared, in this case minus c, is equal to 65. So the b term is missing, so this one is ready to go solving using the square root. So the first thing we do is we go to GEMDES, add and subtract. So we see subtraction inverse operation is add 15. And then we get, that crosses out, and we're left with 2x squared is equal to 80. And so we don't have any more addition and subtraction. Then we go to multiplication and division. Then we can divide by 2. And then we get x squared is equal to 40. Now, we don't have any more addition and subtraction. We don't have any multiplication and division. At this point, we can take the square root of both sides. And the square root is the inverse of the square. And so we get x alone on the left side. But anytime we take the square root, we have to consider plus or minus, because there can be two solutions. So plus or minus the square root of 40. And then we can simplify this radical here. So I'm going to write this over here on the left side, simplification of the radical. So the square root of 40 can be written as the square root of 4 times 10. So we can break this down further. We can say the square root of 4 times the square root of 10. All this is still equal to 40. And we do know what the square root of 4 is. The square root of 4 is 2. So we can say this is 2 square root of 10. But remember, it was plus or minus. So we want to say plus or minus 2 square root of 10. And then this would be the final answer in simplified form. If you left it here, that's almost done. Then we just have to simplify the radical. We have another example over here, example 2. And we're still sticking with the process of GEMDES up here. And we see that we have, this looks a little bit different than the standard form here, but we see that we have the square by itself. So actually this would just be looking like that the b and the c were both 0. So now we're just left with ax squared, and that works to solve this as well. We have addition and subtraction, but that is inside the group, and the group is what we do last. So we're going to skip that, and we just go to the multiplication here. So multiplication is the inverse. So we're going to multiply both sides by 3. So 3 times 1/3, that's why we wanted to cancel that. So that cancels. And then we're left with x minus 4 squared. 11 times 3, that's equal to 33. And then we can take the square root of both sides. So we take the square root to get rid of the square. And anytime we take the square root, we need to do plus or minus. So our square root cancels our square. So we're left with x minus 4 is equal to, we took the square root, so we have to consider both plus and minus the square root of 33. We can't reduce that. That's as simple as it gets. So that one just stays as is there. Last step is we can add 4. And we get x equals 4 plus or minus the square root of 33. And both of those are, and this is the solution, left as plus or minus